Hi, my name is Rohan, and this is an 8-bit storage device called a register. In this register, bits are stored serially or in sequence. Right now, the number is binary 0, which is also the same as decimal 0. Since it's an 8-bit register, it can store 2 to the 8 values, or 256 different values, ranging from 0 to 255. So to store, for example, the decimal number 195, which is binary 11000011, we would do 11000011. So as we can see, that is this number stored in the 8-bit register. The decimal number 255 would be all bits high, so 11111111 in binary. So this button clears the register, and we can program that by going 11111111. So as we can see, all bits are high, and this is the number 255 in decimal. So now that we understand what the register does, let's figure out exactly how it works. So this register is made up of 8 different D flip-flops. So to understand how the register works, we first have to understand how these D flip-flops work. So here's one D flip-flop built from logic gates, and here's the exact same circuit built from transistors. Both of these are examples of D flip-flops, which are the most basic unit of memory and can store 1 bit each. So the D flip-flop has 2 inputs, one for data and one for clock. So as we can see, this allows us to store either a 1 or a 0. This is a 1-bit storage device. From the schematic of the D flip-flop, we can see that it's really just a gated SR latch with an inverter between the 2 inputs, S and R. A gated SR latch is simply a regular SR latch with the ability to be enabled through this pin here, which in this case is the clock input. In a regular SR latch, there are 2 data inputs, S and R. And when both are high, it causes Q and Q bar to be in the same state, making it invalid. The D flip-flop solves this problem by containing an inverter gate between S and R. This means that S and R can never be the same, so there is no invalid state. It also allows the output of the flip-flop to be controlled by this data input. This also allows the output of the flip-flop to be toggled with just one data input. Since the clock signal is attached to the enable input of the gated SR latch, the output only responds when the clock input is on its rising edge, or high. This effectively stores the value presented on the data pin to Q when the clock signal is high. So the register, which is made of 8 D flip-flops with each output wired to the next input and all the clock inputs wired together, is able to store 8 different bits, all controlled from one input. When the clock signal is on its rising edge, each DFF or D flip-flop stores the value presented by the bit to the left. This causes each stored bit to shift down 1 D flip-flop on each press of the clock pulse, allowing 8 bits to be entered in serial. The input comes from a push button, and the clock signal comes from a 555 timer in monostable mode, which serves as a debouncer, so that only 1 clock pulse is generated when the button is pressed. Thank you for watching this video. I hope you now understand how the 8-bit register works.